heat equation as what you have W by WT is equal to alpha square W square U by W X square, where alpha square is equal to K times rho C. These are the standard notation for density again and all. Now, if we consider alpha square is equal to 1 by A, then we have this will be 1 by A W square U by W X square is equal to W by W T. Again, or we can write this as W by W T minus 1 by A W square U by W X square is equal to 0. Let this equation 1. So here, if we compare this with the standard format, then we know that this is going to be the parabolic equation. So what I can write is, I can write here, this is UXX is equal to AUT. This is the same equation that I'm writing here. So UXX is equal to AUT. Let this equation 1 with the given conditions. So what we can have is U of 0t is equal to T0. Let this equation 1. U of LT. So this L is the boundary. 0 is the initial value. L is the boundary value for X. So this will be TL. This is going to be 3. And U of X0. So that means when T is 0, so this is going to be F of X, where 0 less than X less than. So if I consider this value be 1. Okay, so this is going to be 1. This is T0, this is T1. 0 less than or equal to X less than or equal to 1. Okay. Then we have, this is 4. So we have equation 1 with the boundary condition T0, T1 and this condition. So consider H be the step size for X, okay, and
Sir,
yes,
the T1 is U of 1 comma T or L comma T?
it is 1 comma T. So I am restricting this to 1. So this is T1. Okay. Because here I am restricting this X in 0 and 1. So when X is 0 and if for any value of T, it is T0. When X is 1 and for any value of T, it is T1. So we have these boundary conditions T0 and T1 with the initial condition for T as when we put T is equal to 0, we'll have F of X only. And here X is running from 0 to 1. So here we are considering S to be the step size for X and A be the step size for T. Okay. Now using this step size H and K, we can approximate this second order derivative and first order derivative as the differences. So what we know is UXX we can approximate as UI plus 1j minus 2ij plus UI minus 1j, and this by h square. and we want ut. So ut is what? Ui j plus 1 minus uij and this divided by k. And so this is the approximation, difference approximation for the finite difference approximation for this uxx and aut. And now if we put these values here, so what we are able to get? Ui plus 1 j minus uij plus ui minus 1 j to a by k, and here you have ui j plus 1 minus uij. Okay.
Excuse me, sir. What is that term in the u axis?
Yes,
So that minus 2 ij you have written or minus 2 u?
minus 2 uij. It should be
Yes, sir.
minus 2 uij. Okay. So that's what we have. Now if you simplify ui plus 1 j minus 2 uij plus ui minus 1 j is equal to ah square by k, and here we have ui j plus 1 minus uij. So if we make this as one constant again, so let us make this as a constant again, and then we are able to get this. So what I'll do is put a square by k is equal to 1 by lambda. Again, so if I consider this as 1 by lambda, so I can write ui j plus 1 is equal minus uij is equal to, this is 1 by lambda, so I can take it on the other hand side and I can write this is lambda ui plus 1 j minus 2 uij and plus ui minus 1 times j. That's what we do. Okay. So if we simplify this, we want to calculate this term ui j plus 1 is equal to, what is lambda times ui plus 1 j minus, this will be, or I'll write plus 1 minus 2 lambda times uij and plus lambda times ui minus 1 j. Is that okay? Are you getting this? Are you getting this? Okay, so here, this is what the formula we can have. Calculate ui j plus 1. Again, now we can have the initial conditions. So with the conditions, what are the conditions? We have u0j is equal to t0, u1j. Okay, or this is n, we can have n sub intervals, unj is equal to tn. So these are the tn conditions where n into h is equal to 1. So n is the number of interval, h is the step size. Okay, and we can have the initial conditions. So this is equation 6. This is equation 7, and the condition given is ui 0. That means when t is 0. So this is f of IH. So this is X, ith term, where I is running from 1, 2, 3 onwards to N. This is equation 8. Okay. And U is known at is equal. So these are the conditions for this. These are the general conditions. Now, if we make this term 0, okay, so this equation becomes independent of Uij term. So when this term will be 0, can you tell me? When this term will be 0. So we can do one thing, put lambda is equal to half. So if I put lambda is equal to half, okay, then we have Ui j plus 1 is equal to Ui j I plus 1 j plus Ui minus 1 j, and this term will be by. Are you getting this equation? This is equation 9. Again, so here, this equation 9 gives us the 3-point formula. This equation 9 gives us the 3-point formula. So we can write this formula is called Bender-Schmidt formula. When we want to solve the parabolic equation or parabolic partial differential equation, then we use the Bender-Schmidt. So here we have two terms. Okay, so this is Ui minus 1j, and this is Ui plus 1j, and this term is Ui plus Ui j plus 1. Okay, because this is the jth row, this is the jth row, and this is the j plus 1. This is the I minus 1 column. Okay, so we can see like that, and then this gives the next value.
Sir,
Okay.
excuse
Yes.
me.
Yes.
Sir, would you scroll up a bit?
Yeah. We can see here. This is Ui plus
Sir, would you
1j.
scroll up a bit?
Okay.
Thank you.
Is that okay?
Yes, sir.
So this is the standard
Thank you, sir.
3-point formula. Okay. So here this is the 3-point formula. Earlier we have used the standard 5-point formula and diagonal 5-point formula. Okay. So here in the parabolic equation we use the Bender-Schmidt method. Okay. And this Bender-Schmidt method gives you the 3-point formula. Okay. And this formula is nothing but this value is average of this two. Okay. So let us try to solve one problem. Okay. So quickly we'll solve one problem. So till that you just go through this. Are you done with this? So can we go for an example? So we have solved the heat equation double square u by double x square minus 2 double u by double t is equal to 0. With the conditions, what are the conditions we have? Ux0 is equal to 0. U zero t is equal to 0. U 4t is equal to 0. Ux0 is equal to x 4 minus x with h is equal to 1. And here we have find the values of u up to t is equal to 5. Okay, so you can see the equation with the initial values and boundary values. Now we need to understand what is given to us. So let the heat equation be double square u by double x square is equal to 2 double u by double t. Again, so here is equation 1 with the conditions that u of 0t is equal to 0, u of 4t is equal to 0, u of x0 is equal to x into 4 minus x. So from here, we can find the value of x are from 0 to 4. So this is for 0 less than or equal to x less than or equal to 4. And we know h is going to be 1. Okay, so we have for x is equal to 0, u of 0, 0. Okay, so when I put x is equal to 0, then this will be 0. So for x is equal to 1, here h is given to be 1. So u of 1, 0. So if I put x is equal to 1, so this is going to be 3. For x is equal to 2, u of 2, 0. If I put here, this is going to be 2. So we have this is going to be 4. Then for x is equal to 3, we have u of 3, 0. So if I put here 3, then I'll get it 3. So for x is equal to 4, again I have u of 4, 0 is going to be 0. Okay, so is there any doubt up to here? Are you getting these values?
Yes, sir.
Okay, so now we got these values, we got these values. So we need to understand what is meant by u of 0t and u of 4t. Okay, so we have the relation. What is the relation? A is equal to AH square again by 2. Again, because here the value of lambda is going to be 2. Again, so since lambda is equal to 2 here, so we can take this value here. Again, now this is equal to, so we have A is also equal to 2. Again, then what this term will be? 2 by 2 into 1 square. So this h is going to be 1. So we can have this is going to be 1 again. So we got k is equal to 1. Okay, we have h is equal to 1, k is equal to 1, and then this initial conditions. Okay, so what we can have is hence we get u of 0, 0, that is 0, u of 0, 1, that is 0, u of 0, 2, that is 0, u of 0, 3, that is 0, u of 0, 4, that is 0. These are the values of t. Okay, and then what we have, u of 0, 5 is equal to 0. Also, what we have, u of 4, 0 is 0, u of 4, 1 is 0, u of 4, 2 we know is u of 4t is 0, and u of 0t is 0. So these are the conditions 0t, and these are the conditions 4t. So this is 0, u of 4, 3 is 0, u of 4, 4 is 0, and u of 4, 5 is 0. Okay, so these are the conditions that we need to understand. So is there any doubt in these conditions?
Sir, how we got A is equals to 2?
Yes. Again, so we can have here. When we have started here, I have written this equation. Uxx is equal to AUT. Is that okay?
Yes, yes, I got it.
Okay. So if we compare it to the standard format, then we get A is equal to 2. Okay. So we got this one. Now, so using these conditions, we have to make a table. Okay. So consider following by Bender-Schmidt method. So we are using Bender-Schmidt method to find the intermediate values. Again, now we can have here. This is x direction. Okay, and this is t direction. Okay. So here we have I, and this is going to be j. Okay, so the value of I are 0, 1, 2, 3, and 4. Okay, so these are the values we have. Now for j, we have 0, 1, 2, 3, 4, and 5. So we have to find the value up to t is equal to 5. So now think of the given values. So we know at 0t, this is going to be 0. At 4t, this is going to be 0. Okay, then we have calculated the value for j. So it is going to be 3, 4, 3, 0, 3, 4, 3. So is that okay? Now, what is the formula? So the formula is, this is ui minus 1j, and this is ui plus 1j, and this is ui j plus 1. So ui j plus 1, ui j plus 1 is equal to ui minus 1j plus ui plus 1j by 2. So actually, this value is average of these two. Okay, so now think of this value. So this value will be average of these two values. Okay, so this value will be average of these two values. So can you tell me what will be the average? Is it 2?
Yes, sir.
Okay, now this value will be the average of these two. So what will be the average? Is that 3? And this value will be the average of these two. So is that 2 again?
Yes, sir.
This is comparatively easy. Okay. So now, next, what we can have? Next, I'll have the average of this value and this value. So is it 1.5? Are you getting this? So this value will be average of this two. This value will be average of this two. Now we have, this is 0.5, this is 1.5, and this is 0.5. Are you
So
getting?
how that is 0.5? That should be 1. No?
Average of this 0 and yeah, this is 2. Wait. Okay. So this is 2. Okay, so it will be 1 year. Now what we can have, this will be 0.75, this will be 0.75, and this will be 1. And this value will be 0.5. This is 7.5, and this is 0.5. Is that okay? Are you getting this?
Yes, sir.
Okay, so this is the Bender-Schmidt method to find the solution of one-dimensional gate equation. Yeah, this is how we are able to find. So what is important? You need to find these values, and these values. Okay, so once we know these values, and these values, so you can use the 3-point formula and then calculate all the values in between. So is there any doubt